Welcome to the next lesson in our module on basic Java features for developing Android apps, which introduces you to the concept of Java expressions that can produce values. After completing this lesson, you will understand Java's arithmetic operators and their sometimes interesting behavior. You will also know how some of Java's specialized assignment statements allow shorthand notation for common assignment operations that occur frequently in practice. Finally, you will learn the concept of type compatibility in Java and its relationship to assigning values to variables, as well as recognize how typecasting can allow you to selectively modify Java's default assignment behavior. Next, we'll explore the expressions that can appear on the right-hand side of an assignment operation. An expression is simply a value or operation that produces a value. The simplest expression is a literal value, which simply produces it itself. More complex expressions can be created using operators and parentheses, just as in mathematics. Arithmetic expressions can be created using the standard set of mathematical operators for addition, subtraction, multiplication, and division. There is a fifth operator, the percent sign, that is the mod operator. But before we discuss the mod operator, let's briefly talk about the division operator. Now, division works as one would expect if one of the operands is a floating point value. And in that case, you get a floating point result. But when both operands are integers, you get integer division, which produces an integer result. The integer result is truncated and not rounded. So if you divide the integer 14 by the integer 4, the result is the integer 3. If you did not want integer division, you would have to make one of the operands a floating point value, and that could be accomplished by simply adding a 0.0 to the literal value. Now, the mod operator can be used to produce the remainder that occurs after integer division. So when we divided 14 by 4, the answer was 3, but there was a remainder of 2 that was lost. The mod operator allows us to get that remainder, and thus 14 mod 4 produces the value 2. Students new to programming often wonder what such an operator is good for, but it is interesting just how many applications it has in computer programming. It can be used to easily determine if an integer is even or odd. We can determine that by doing mod division by 2 and seeing if the result is 0, meaning that the number was even, or 1, meaning that the number was odd. When creating expressions, you can use parentheses just as you do in mathematics to force a specific order of operations. In the examples shown, we can use parentheses to force the addition to occur before the multiplication, or to force the multiplication to occur before the addition. Without parentheses, we will use the standard rule of precedence to determine the order of operations in evaluating an expression. The rule of precedence are similar to mathematics, where our unary operations have highest precedence, followed by the multiplicative operators, which are then followed by our additive operators. When binary operators have equal precedence, they are evaluated left to right. And in this example, we see that the leftmost addition will occur first, followed by the subtraction operator, and then finally the rightmost addition will occur last. When unary operators have equal precedence, they are evaluated right to left. When the operands of an operator are mixed ints and doubles, the result will be a double value. The compiler will automatically convert the integer value into a floating point value so that floating point arithmetic will be used. So if we multiply 4.2 by 3, the integer 3 is converted to a floating point 3.0 for the multiplication, and the result is a floating point 12.6. Now this conversion is done per operator, affecting only its operands. So given the displayed expression, the first operation to be performed is the leftmost division operation. Since both of its operands are integer values, we get integer division, and the integer value 2 is produced. The next operation to be performed is the multiplication. Since its operands are mixed, the value 2 will be converted to 2.0, and the multiplication produces the value 2.4. The next operation is the rightmost division operation. Again, since both of its operands are integers, we get integer division, and the result is the integer value 1. Finally, the addition is performed to produce the value 3.4. Because programmers perform certain operations again and again, Java provides several specialized assignment operations that ease the writing of code. In particular, Java allows the assignment operators to be combined with arithmetic operators so that it becomes easier to update a variable. For example, we often want to update a variable by adding or subtracting a value from the variable. In this example, we want to update the variable time by adding 10 to it. This can be done more compactly using the plus equal operator that performs addition and assignment in one step. This can be done with all 5 mathematical operators. Note that the expression on the right-hand side of the specialized operator is fully evaluated before the specialized operator is performed. This is important if the expression on the right-hand side has lower precedence operators than the specialized operator. Another common operation is to increment or decrement a variable by 1, and Java provides special operators for this. The plus plus operator is the increment operator, and it will increase the value of a variable by 1. Similarly, the decrement operator is minus minus, which decreases a variable by 1. These operators are easy to use, and they're important to recognize when you read code written by others. So if you ever need to increment a variable, there are several ways to do so, and you are free to choose any of them. One is not necessarily preferred over the other, as in the end, the same code will be executed. Similarly, there are several ways to decrement a variable, and you can use any one you wish. But before we move on, let's talk a bit more about the increment and decrement operators. Besides incrementing or decrementing a variable, these operators also return a value. In the case of pre-increment, where the plus plus operator precedes the variable being incremented, not only is the variable incremented, but the new value is returned as the result of the expression. In the case of post-increment, where the plus plus operator follows the variable being incremented, not only is the variable incremented, but the original value of the variable is returned as a result of the expression. In most cases, we are only using these operators to increment a variable, and we ignore the return value, in which case you can use either pre-increment or post-increment. Returning to the topic of declaring variables, a variable is said to be uninitialized if it has been declared but not yet assigned a value. In Java, the compiler will not allow you to use a variable that has not been initialized. So it is good programming practice to give a variable a value when it is declared. This is called initialization, since it gives the variable an initial value as soon as it is created. This is accomplished by combining variable declaration statements with assignment statements, though we call it initialization rather than assignment in this situation. For example, we can declare a character variable grade and initialize it with the character A. When the compiler allocates space in the computer's memory for the variable grade, it will give it an initial value at the same time. The final concept that we are going to discuss in this talk is type compatibility. Java is a strongly typed language, and thus it does not allow certain type of assignment statements if those assignment statements could potentially lose information. For example, Java will not allow you to assign a floating point value to a variable of type int, since that variable cannot store the fractional part of the value, and thus information would be lost. But Java does allow certain conversions. As such, it is okay to assign an integer value to a variable of type double. In such a case, the compiler will automatically convert the integer value into a floating point value, since such a conversion will not lose information, and then assign the converted floating point value to the variable of type double. This automatic conversion that is made by the compiler is called a coercion. So in Java, you are allowed to assign a value of one type to a variable of another type as long as the type of the variable is further to the right in this chain of types. For example, you can assign a variable of type short to a variable of type int, or a value of type int to a variable of type double. But the compiler does not allow assignment to variables whose type is to the left of the value type. If you ever want to assign a value to a variable whose type is to the left, you can only do so by using a typecast. A typecast will change the value from one type to another type, even if that conversion may lose information. But you have to explicitly state that you want that conversion to happen. The way to specify a typecast is to specify the desired type inside parens in front of the value you want converted. In this example, we have a floating point value 9.0 assigned to the double variable distance. If we want to assign this value to an integer variable points, we must specify the type int inside parentheses. This will get the value of the variable distance, convert that value to an integer value, and then assign the resulting integer value to the variable points. Note that this conversion is only performed on the value taken from the variable distance. It does not affect the variable distance. The variable distance is still a variable of type double and it still holds the value 9.0. And it is important to note that the conversion of a floating point value to an integer value is performed by truncation rather than rounding it. This lesson gave you an overview of Java expressions, focusing on how we can use them to compute new values. Now that you have completed this lesson, you should understand Java's arithmetic operators and their behavior. You should also know the shorthand notation of Java's specialized assignment statements and understand when and where to use them. Finally, you should have learned the concept of type compatibility and type casting, which are important to understand when writing correct Java programs for Android.